Okay, am I live? Let's see here. I think I'm live right now, actually. Let me check it out. Yeah, I think I'm live. Okay. Hello? I'm gonna try to do some recursion. I think I'm live right now. Okay, yeah. Alright. I am live. Woohoo. Just to test out though, I'm gonna watch myself on another channel. Okay. Okay. Wow, that was like 20 seconds. I don't think I'm getting any, let's see if I can. That's unfortunate. Okay, but we'll see here. That's unfortunate. Okay, but we'll see here. Do I have chat enabled? I think I do. Okay, but we'll see here. Do I have chat enabled? I think I do. Okay, but we'll see here. Do I have chat enabled? Okay, that's recursive. slower than the bit rate? Oh, that's unfortunate. Hey Adrian, are you watching this? If you are, type something in the chat. Okay. Oh, okay, so my bitrate is sort of low. That might result in lag. should I just start doing math problems anyway, and then like if people would come, they can just tune in and see me solve. Like, by the way, can you like see my questions? I know. This might be pretty fun. Like, it's just another way of engaging in social interaction, you know, which might be trying to be fruitful. Can you see my questions clearly? Okay, so looks like my face is like in a considerable portion of the screen. Actually, like I might want to like move it here. Okay, guys, I hope this is entertaining. This is my first time ever to stream, and honestly, I really have no idea on how to do this, but I hope it'll be good. All right. Actually, let me just turn on the chat. So, I think there's a chat box here. Here's the thing, like, okay, it's 8:22. I am going to start in 3 minutes, so I'll be starting at 8:25, and then this will be a 75-minute test, so it's projected to end at 9:40. And then after that, I'm going to check my answers, and then go through the questions I missed. So the stream will probably end like around 10:30, the latest. Yeah, so if anyone watches, that's cool. If not, then that's also cool. But yeah, it's gonna be good. Okay, I can't see if there's anyone else in the stream. So, like, I don't know. Maybe I'm gonna need to, like, turn something on to check that out. Okay, I'm going to start right now. So let's go to tools, scripts, timer, and start. Okay, so let's look at the problems. Let's see. Okay, so this is a mock test I got from AOPS, and then the problems are supposedly AMC difficulty. So supposedly not that hard, but since this is sort of late in the night, I might be kind of sloppy. But anyways, let's get started. Okay, so problem number 1: a red container is filled with water. 20% of the red container is poured into a blue container. What is the ratio? Okay. So it's 80% to 20%, and it's it's a ratio between blue to red, so that would be 1 to 4 since it's 20/80. Okay, I'm using purple tonight, I guess. What is the smallest positive integer such that it is less than 1? Okay, so this is 5/6 plus 1 over n less than 1. So 1 over n is less than 1 over 6. That means n is greater than or equal to 7. So 2 would be D. 3, a rectangle is area of 22 square inches. If the height of the rectangle is 1 inch shorter. Okay, so that means that the width is 4 square inches. And that means that since the area is 22, then the height is 11/2. Just to make sure, it's because, so like 4h minus 4h minus 1 is equal to 4 exactly. So then the height is 11/2 and the width is 4. That means that the sum, and if you divide it 2, 11, 8, so you get 19. So 3 is E. 4, let fx is log 9x, and let gx be a function such that gx is fx squared. Okay, so then gx is log 9 of x squared. And then it's asking for the equivalent, so it's 2 log 9x. But also notice that x squared is always positive. But since x is defined on the logs, x is always non-negative either. So either way, so it doesn't really matter. But since 2 log
2 log 9 is essentially just log 3. So then it's just log 3x. Debating whether or not to add the absolute value. Since I think it's redundant, since the domain of x for f of x is log 9x is already non-negative. Oh, no. Since it's gx is equal to f of x squared, and f of x squared is non-negative, but doesn't add any specific restrictions for x. That means it has to be there has to be an absolute value. So 4 is B. Okay, let's move on to 5. There are 10 students in a classroom with 12 chairs. Before lunch, each student chair randomly chooses. Okay, if no 2 students choose the same chair after lunch, what's the probability that every chair has been sat on at least once? So it's 10 people with 12 chairs, and they do a shuffle. So really it's 1 minus. Let's do reverse counting. So the probability that not every chair has been sat on at least once. So that means that there is 2 scenarios. So the first scenario is there's 1 chair left out. And the second scenario is there are 2 chairs left out. So let's look at the first scenario. So if there are 2 chairs left out, then it's the same 10 chairs. So then it's just a shuffle between these 10 chairs. And the probability that this happens, plus the fact that nobody sits on the same chair, would be, so for the first person, you would have like 9 out of 10 options, second person. Okay, well, you can also do that with reverse counting. So then that would be 9 fact out of 10 times 10 divided by. Is it actually that complicated? 1 minus 9 fact out of 10. And then this is... Okay, no. There has to be an easier way to do this. Choose the chair. So I'm actually gonna skip this for right now. I think I misread, but the time's sort of pressing. Okay, this person writes down all the divisors of 144 and erases some of the divisors. Product divisible by 18. Okay, so 144 is 12 squared, so that's 4 squared, 2, 4, 3 squared. No 2 divisors divisible by 18. So 18 is a 3 squared too. And since he writes out all the divisors, then essentially, so the largest power. So you can have like excess powers of 2. You just can't have excess powers of 3. So 3 has to be the limiting factor, so to speak. So then maybe you can have like 3 times 2 to the 4. And then you just can't have 3, so you're just gonna have to first you have 5 times 3, so you have a total of 15 divisors. And then you have those that are automatically divisible by 18. So those that are divisible by 18, so you have 5, not 5 of them. So 1, 2, 3, 4, you have 4 of them. So then you have to erase those 4, so you have 11 left. And then it says that the product of no 2 divisors. And then, so when you think about like having 2 divisors that are divisible by 18, really the control factor is 3 squared. So you can have at most one number that has a 3 in it. That means that, so the numbers of numbers that has a 3 is 5, right? Since there's 3 to the 0 to the 1 all the way to 2 to the 4. So you can only keep one of them, so you have to erase 4 more. So 11 minus 4, that would give you 7. Let's see if 8 is a possibility. Like so, no, but then you'll have to also eliminate the 2's, which just makes it worse. So I'm pretty sure the answer is 7. Right here, so the answer 7 would be A. Okay, moving down to number 7, ABC are positive reals such that A over BC is 1 over 3, ratio of B. Okay, so A over BC is 1/3, B over AC is 1/12, and C over A plus B is 1/8. Okay, so this is really a 3 equations here, and you're really just looking for a trick way to solve this, or a faster way. If you multiply 1 and 2, so 1, 2, 3, so if you multiply 1 and 2, you get 1 over c squared is 1 over 36, so you get c is plus minus 6, and since they're positive reals, it's plus 6. So then 6 over a plus b is 1 over 8, so then a plus b is 48, and then you also have a over b is 2, so a is 2b, so then 3b is 48, so b is 16, and a is 32. Voila. What is b plus c? Okay, so b plus c is 16 plus 6, so that would be 22. Answer is A. Tip 8. The figure below, 10 pairwise externally tangent circles of radius 1 are in a triangle. With the outer circles tangent to the sides of the triangle. I'm going to find closest to the area of the triangle. Okay, so you have 10 circles stacked up together. And then, essentially, you're looking for the area. So, you need to find the sides. Since the circles have radius 1, so this is what it looks like. And since it's equilateral, we're really just 1, 2, 3, 4, 5, 6, and then something like that. So you have these types of triangles as well. So this is the side. And this, here you have 6 1s. Then here is a 1, here's 30 degrees, so this is root 3. This would be 2. Okay, so root 3, 6. So it's 6 plus 2 root 3, that's the side length. And the area for an equilateral triangle is a squared times root 3 over 4. So then this thing squared times root 3 over 4. Expand that, that's 36. 4, 3, that's 12. 2, 12, 24 root 3. Root 3 over 4. That's 48 over 4. So 12 root 3 plus 26, 6, 3, 18. Root 3 is 1.71. 32, just to make sure. So that's 17.132 plus 3.426. 20.5, so that's 21. 21 plus 18 is 39. Okay, so yeah, so B. Number 9. In the rectangle ABCD with AB5 and BC4, let E be a point on CD, given that AE bisects BCD was the length of AE. Okay, so you really want to draw a diagram when it comes to these problems. So you have AB5 and BC4. E be a point on CD such that AE bisects BED. BED. That's the angle. Okay, so something like that, and then these two angles are congruent. What is the length of AE? So a bisector. And so if you have a bisector, then you might be able to make some congruences. So for example, if I draw a line of perpendicular over here, then technically, so if I say that this is h, then ADH is congruent to, or sorry, ADE is congruent to AHE. So ADE congruent to AHE. That means that this is 4, so this is 3, and then this is x, and this is y. And just bear with me for now, so that this is 5 minus x, and this is 4. So you have an equation subject to x, and we really want to find out is y, so we just need to solve for x. So then you have x plus 3 squared is equal to 16 plus 25 plus x squared minus 10x. And it's x squared plus 6x plus 9. So you cancel out the x squares, and you move the x over, so it's 16x is equal to 725, so that's 32. So x is 2. I like these numbers, 2. Okay, so, and then 2, 4, so that would be a 1 to 2 to root 5 ratio. So then y would be 2 root 5. Check that out. Yep, 2 root 5. So the answer for 9 is B. Okay, so far we're doing pretty good. What is the value of sine pi sine 2 pi? Okay. This is actually, I don't remember exactly what the formula for a continuous product of sines are, but I'm pretty sure we can derive that fairly easily. And we do this with complex numbers. So if you say that, so like, essentially we're looking for the product of like I, 0 is like an infinity, but like to n, probably from 1. So it's sine of like I sine of 2. How about like ki, or something like that, where like k is a constant. So then that is the imaginary part of e to the I. Okay, yeah. I is a bad variable here. So how about you just say like k alpha. So we're doing k from 1. So then we're really looking at the imaginary parts of e to the ik alpha. And so that's equal to 2I over e to the ik alpha minus e to the negative ik alpha. And so let's see if the IM operator is distributive, which means if I can bring the IM operator out of the product. And to test this out, we just to see if e to the k alpha minus e to the negative ik alpha. Also, the two i's definitely come out, and then e to the I2k alpha minus e to the negative I2k alpha. And this is e to the I3k alpha. This is negative e to the I3k alpha. And then you have two subtraction terms, but we have plus. So no, it looks like it's not distributive. Then the derivation process might be a little bit, actually, maybe it's not that hard. Just notice that cosine pi over 2 minus x is equal to sine x. And this is, if you look at something like this, this is theta, this is pi over 2 minus theta. And then these two are congruent triangles, so, okay. So then, okay, it's from 6 pi to 11 pi, and there you have you have 11 minus 6. So you have 6 elements at the bottom, the denominator, and 5 elements in the numerator. That means there's an extra element, but all the other ones cancel out. And the extra one is cosine 6 pi over 24, which is cosine pi over 4. 1 over that, technically. So then cosine pi over 4 is radical 2 over 2, so then it's radical 2. So the answer is E. Okay, yeah, this is overkill, but it would be interesting to find out what the actual closed form formula is, since that might be helpful. Alright, number 11, let A, B, C be reals that satisfy A plus B plus C is 1, A plus mod B plus mod B. Okay, so what is A squared plus B squared plus C squared? Essentially you have A squared plus B squared plus C squared is equal to 4 plus 5 plus 8 minus 1, so that is 12, 19, 18, right? So 18 over 2, so that's 9. And A plus B plus C is 1, so then see the difference here. And so this is suggesting A is negative, right? Actually, you can do this by like taking a difference. So if you subtract 9 with 8, which is absolute A plus absolute B minus plus C, so then you have C modulus minus C is equal to 1. And then you have, say, like B modulus minus B is equal to this is 4, then you have A modulus minus 8 is equal to 3, here, no, to 5. And just to check this, you can add both sides, and that makes sense. And what that means is that all these numbers are negative. Hold on, no, that doesn't make sense, because if all these numbers are negative, but then if one of them is positive, then there should at least be one that is 0. Okay, so that's very suspicious. Okay, yeah. Oh, whoops, this is not 9, this is 8. Because 4 plus 5, that's 12. Sorry, no. That's 9 plus 8, that's 17. Okay, so yeah. So, this is 0, 3, and 4. Yeah, that makes sense. So C is positive. And then all the others are negative. And then really, so this is negative B, so then B is negative 3 over 2, and A is negative 2. And C is, and so now you can see that C is 2 plus negative 2 plus, or 3 plus 3 over 2, so that's 9 over 2. So then A squared plus B squared plus C squared is 4 plus 9 over 2, 9 over 4 plus 81 over 4, which is 90 over 4, that's 45 over 2 plus 45 plus 8 over 2, so that's 53 over 2. That would be A for 11. Moving down. But PQRS, not exactly distinct, P primes it says that P squared, P is equal to Q squared plus R squared plus QRS. Second smallest possible value of P. So P has to be sufficiently large. Since it's the sum of 3 times. That means that p has to be odd. Okay, so assuming Q and R and S are distinct, then P has to be odd because it's large. But if Q, R, S are all odd, then Q squared is odd, R squared is odd, S squared is odd, and QRS is also odd. That means that P is even, which doesn't make sense. Otherwise, either one of them is equal or one of them is odd. But the equal argument also doesn't make sense, because even if they're equal, so like, let's just say two of them are equal, but if they're both odd, then the argument still holds. It means that one of them has to be even. If one of them is even, then even squared is even, and then QRS is also even. But then P is still even, so then two of them have to be even. So then at least two of them is odd. So then, without losing generality, let R squared and S squared, or let R is equal to S is equal to 2. So that means that Q squared plus 4Q plus 4 is equal to P. Alright, what does this look like? This looks like Q plus 2 squared is equal to P. So then P is a perfect square. But then you can't really be a prime if you're a perfect square. So that also raises issues. Alright. Oh no, R squared is 4. Sorry, no, that would be 8. So that means that Q squared plus 2, Q plus 2 squared plus 4 is equal to P. Then really you can just start plugging in numbers. So does 2 work? No, 2 doesn't work. Does 3 work? That's 5. 29, 3 works. Then how about 5, 7 squared, 49 plus 4, 53 also works. So then the second smallest would be 53. So the sum of the digits is 8. 8 gives C. Alright, moving down. 13. Alright, take some water real quick. So positive integer n is called toasty for all integers m greater than equal to 1 and less than n. There is a positive integer k such that k plus 12. Okay. Toasty. That does seem toasty. So then we can fiddle around with this. So it's 1 minus 12 over k plus 12 is equal to m over n. And then k is positive, so for all integers. This might be S of ft. Let's see. We have no. This is not S of ft, since there's no cross product between m and n. But exactly 12. That should be pretty rare. Yeah, as the choices suggest, you don't have a lot of those numbers. But exactly 12. So if you say that m is 1, then n has to be at least 13. Right, since k is positive, k has to be at least 1. So then n over n has to be at least 1 over 13. So n has to be at least 1. Or, has to be at least 13. Then I guess, like, the brute force way is to just try numbers starting at 13. But I think there should be some pattern to these numbers. So m is equal to n minus l, where l is 1, 2, n minus 1. So then it's n minus l k plus 12. So it's nk minus lk minus 12l plus 12n. So then 12n minus 12l minus lk is 0. Or in other words, 12n is equal to l times 12 plus k for all l that's in this interval. So from 1 to n minus 1. What that means is that so then 12 is a divisor of l times 12 plus k. And since there are definitely l's where neither 2 nor 3 are divisors of it, that means that 12 has to be a divisor of 12 plus k. Which means that 12 is a divisor of k. So then really it's m plus n is equal to something like 1 over p, like h plus 1, since k is equal to 12h. And this is for all m. Now this doesn't make sense either, because, oh boy. What to do here? Let's try this again. Okay, so m over n is equal to 1 minus 12 over k plus 12. And then if you do the substitution, so then l over n, 12 k plus 12. 12n is equal to k, l times k plus 12. Yeah, so all this is legit. And since there always exists an integer k such that this equation holds, so we thought about divisibility. That doesn't make sense. Okay, I can't come up with an idea to deal with this right now, so I'm going to leave this for now. Let's move on to number 14. Okay, so it's the Gaussian function. Let n be the number of n such that n plus 1 minus, okay, n plus 1 prime is equal to 4. If you just try some values, you have like 6.28, right? So if n is equal to 1, minus 3.14, that goes to 6, 3, so that's 3. How about 9.42, 3.14, or 6.28? 9, 6. Okay, so there is some critical point where, like, the 0.14s stack up to over 1. So for example, so when n is 7, you can see the difference. So if n is 7, then 17, so that's 21.98, it's 21. And if n is 8, that is 25.12. So then that's 25 minus. Okay, so essentially it's asking for the number of times the 0.14s cross over. So 0.14 times 7 is equal to 0.98. And then so 0.14 times 14 is equal to 1.96. And then times 21, 2.94. So every time it decreases by 2, then you want to get to the point where it goes to 0, 0, but 0, 0 still counts. So then this is 0.02. So how many times does that have to happen? Well, then really, it's just, right, since another 0.14, that's 6 times. If you trace that down, so 28, that's 92, 35, that's 90, 42, that's 88, 49, that's 86. So yeah, 6 more times. And then, so it all works before 49, but then if you go to 48, if you go to, sorry, what is it, plus 7, so that's 56, then it goes to 84, so 57 is 80, is 98, so then the cycle begins. This is 57 here. 56 doesn't work. 57 works. And then and then you just keep on adding 7s. So 57, since 98 is divisor of 7, so it would be 99. But basically, it's just a number. It's just 100 over 7. That would be 14. I mean, we can also write it out to just make sure, right? I'm pretty sure 64, 73, no, 71, 79, 87, 94. Wait, hold on. 71, 278, then 85, and 92, and then 99. So if you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 sevens. So the sum of the digits of n is 1 plus, no, it's 14. Okay, yeah. It's 14, whoops. Okay, so 1 plus 4, that's 5. So 14 is A. A be the real part of randomly chosen solutions, Z to 27 is 1. B to the real part, Z minus 1. Okay, so then it's the 27th root of unity, so that would give you 2k pi over 27, and then this is 2k pi over 9. So for A to be greater than B, you basically have to, since it's just cosine of 2k pi over 27 is greater than cosine of 2k pi is over 9. Well, we should really differentiate here, so L pi. And then, if you look at the graph of cosine, whoops, that's sine. So this is 0 pi over 2 pi here, 3 pi over 2, and then 2 pi. So then if, essentially you have two intervals here, two different types of intervals. So here it's monotonically decreasing, and then here it's monotonically increasing. So if these values are between 0 and pi, then 2k pi over 27 is greater than 2l pi, or is less than 2l pi over 9. That means that k is less than 3l. So for these that are less than pi, so for l to be, so then L has to be 4, or less than or equal to 4. And K is less than or equal to 3L. So K is less than 12. Oh no, maybe we should just like fix L. Yeah, let's just fix L. 0 to 8. Okay, so if L is 0, then there's no solution. If L is 1, then either, so then K is either less than 3L or 2k pi over 27 is greater than 2 pi minus 2L pi over 9. Divide 2k is greater than 54 minus 6L, or 27 minus 3L. And note that k is less than 27. Really, it's less than or equal to 26 since k is an integer. So that's between 1 through 4. And then for 5 through 8, it's the other way around. So starting from 5, it's either k is greater than L, so k is greater than 3L, okay, or k is less than 27 minus 3L. So these should be symmetric, like the gut feeling tells me they are. But let's just be safe here. So k is less than 3L, then you have 0, 1, 2. K is greater than 27 minus 3L, 24, so 25, 26, 27, 25, 26. So then it's 5 for 1, and then for 2 it's 0 to 5 plus 21 to 22 to 26. So that is 5. Right, 26 minus 22 inclusive. It's 5, so that's 10. 3, that's 8, 9, 27 minus 9, that would be 18. It's greater than 18, so it's 19. From 19, from 26 to 19, that would be 8, so it's 16. And then hold on, what is it? It's 24, and then it's 21. 25, 26. And then there's a 0 to begin with. Oh no, so this should be 11 since k is less than 6. It's 0 through 5, yeah. 17, and then 4, that would, as you would expect, that would give you 11, 11, 1, so that's 23. Just to make sure though, so k is less than 12, that's 12, k is greater than 27 minus 12, that is 15, so 16, 26, yeah, okay, so 23. Now 5, so k is greater than 15, or k is less than 27 minus 15, or k is less than 12. K is greater than 15, so 16 and 26 is inclusive, so that's 11. And then 12, 0 to 12 inclusive is what is 0 to 12? It's 12, so it's 20. Okay, yeah, so I would say this is symmetric, like actually. Then it's 5 plus 11 plus 17 plus 23 times 2 over 27 times 9. So if you add this together, this is 28. 28 again, 56 times 2, 112. 112 is 56 times 2, so that's 7. No, yeah. It's not divisible by 3. And it should be 112 over 243. So that would give us what? That would give us A. Alright, okay, we have exactly 30 minutes, and we blanked 2 of them, so I'm not doing so great tonight. How many sequences? First, 8 positive integers, and A8. That are there such that A21. So if A is odd, then it's increasing, and then the even integers within the sequence are listed in increasing order. Okay, so it's just a fancy way of saying A1 to A8 is a permutation of the integers from 1 through 8. And then so A21 minus 1 is less than A2i. So for index, odds are always greater than evens. And then, so what that means is like, so A2 is greater than A1, A4 is greater than A3, or no, A6 is greater than A5. So that's the 2 requirements for this. And then for all even I, so then A4 is less than A3, and A8 is less than A7. So then if you randomly, okay, so then 2, 3, 6, 7 are like the greater ones, and then 1, 2, 3, 4 are the smaller ones. So then it's natural to partition that into. You also have to ensure all the even integers are increasing. So if I do like 8 choose 4, then I can always find 4 integers that are like larger. That's not true. It's not necessarily true. Oh shoot. I feel like I'm pretty close to solving this, but I can't find a good way to partition the set. 1 through 8. Essentially, you have to have a number that's greater than or equal to 6. Otherwise, yeah, so and also you have to have like 8 in these sets. But then 8 can pair with anything. But if 8 pairs with anything other than 7, then 7 also becomes the greatest. Okay, so I think we can just do casework. So 8 has to be contained in the set. And we can just basically say that if 7's not in the set, then 8 has to be paired with 7. Otherwise 7 is in the set. And then again, if 6 is in the set, then 6 has to be, or if 6 is not in the set, then 6 has to be paired with either 7 or 8. And then if it is in the set, then we move on to 5. But this is also not a good way to count. Might have to skip this as well. Oh boy. ABC, a trapezoid. Maybe a less than CD. Okay, so that's a trapezoid that looks like this. ABCD. Midpoint of AD. BM is 6, and the area of ABCD is as large as possible. What is AB plus CD? Okay, so if the area is as large as possible, then there must be some parameterization. Also note that this is root 11. So then if AB is x, then CD is 2 root 11 plus x. Oh no, this is not that simple. That side here is 6. Okay, so if I drop in h in altitude, then this is 25 minus h squared. This is 36 minus h squared. So then 2 times 25 minus h squared plus 4 times 36 minus h squared. That's the two sides, A, B, and C, D. And then so multiply that by h. This is what you want to maximize. and h is less than 5, or equal to 5. Is there some inequality that does this? We can take the derivatives. The derivative is these two added together plus h times negative 2 minus 2h over 25 minus h squared plus 4h over 36 minus h squared. You want to set that to 0. The solution isn't really guessable. The solution may be pretty wacky. Maybe there's like some better parameterization that I'm just not seeing. Maybe I should try one of maybe like if I do like a theta, things would get better. I don't know. Oh shoot, I'm running low on time. Yeah, I think I screwed up. Honestly. This is not fun. Oh, you know what? It's okay. So if we do a theta parameterization, but then there's still a square root. So the simplest way to parameterize is by h. But then I need to find a way to optimize this. Honestly, this is not looking great. if I say let's say AB is X and then CD is Y. What you really have here is Y minus X over 2. X over 2. There's just no good way to express the area. This is it's annoying. Yeah, I'm gonna try to work on questions that I skipped. So number 5. Boy, I don't know. What's a good way to deal with these problems? Okay, yeah, no. This one's This one's not as complicated. 12 chairs. So then if they sat on 10 chairs before lunch, then so 2 people have to sit on those 2 chairs. And then the other 8 people sit in the first 10 chairs. So it's just 10 choose 8, right? And then all the possible seatings is 12 choose 10. I think so. So that would be 45 over 66, which is 15 over 12, or 12 over 15. That would be E. Okay. What was the other one? It was 13, yeah. 13, okay. So for 13, it is pretty small, like, let's try it again. So like, how about let's try like isolate K this time. So over here we have Kn minus Km is equal to 12m. Then K is 12m over n minus m, which means that n minus m divides 12m for all m. Then what does this, well since it has to hold for all m, so let's try m is equal to 1. So n minus 1 divides 12. So then this is good for 13. 7, 5, 4, 3, and 2. So then these are all the possible candidates. And then if we try this again, we have n minus 2 divides 24, so on and so forth. Okay, so yeah, so that really reduces the search space. This is 24, then 26, but no, we just want to look at the ones on the list already. So 3 is good, 4 is good, 5 is good. What else? Oh yeah, and 2 is good technically. But 2 is like out of consideration now. So then you can go on. But basically we can just like test out 2, 3, 4, 5. 2 automatically works. 3 automatically works. And so for 4, what is it? 4. Yeah, 4 works. And then 5 is 1. Okay, so it should be 4. 4 integers. The answer for this is D. Okay, let's see if we can work out 16 with like 6 minutes left. Okay. I still think we have to do some weird casework. That's like the weird part. Like, let's look at 17. I feel like 17 is a question we can actually bang out. So since that derivative equation is like super hard to solve, we're gonna look at this instead. So really, we're just looking at half the diagram. Oh yeah, I misread. Okay, that's so stupid. Yeah, M is the midpoint of AD. Okay, bro. AD is BC is 5. Okay. So then BM is 6. Okay. Oh boy. Alright, and then we want to maximize ABCD. Okay, so we extend that. It's like some intuition. And then these two sides are similar. Actually, no, these two sides are congruent. So then it suffices to maximize BCE. Alright, so that's 5. That's 6. That's also 6. So 5, 6. So then the angle BC has to be perpendicular for that to happen. So BC has to be 90 degrees. Okay, and then we just need to find AB and CD. And it's exactly the sum, so then it's root 36 plus 25, and that's 61. Wait. No. That's 512. Okay, so this is 144, so then it's 169, which is 13. Okay, so then C is 13. Yeah, that makes sense. Okay, so yeah. The problem is actually not that hard. I feel like if I actually read the question. Okay, for 18. A few students in Mr. G's class takes a 10-question quiz. There exists a student who got exactly those questions correct. Three students got a perfect score. So 3 students got 10 questions correct. And then the fraction of them that got over 10, well, yeah, that makes sense. So it's some way to partition the set. And the only thing that matters is the number of questions they get correct. So Mr. G might have like a substantially large class. The people that got over... So the people that got over 9 questions correct is 3. So 1 minus 2 to the, like, x minus 10 equals to 3. That's like negative log 2 of 3 plus... That doesn't make sense. Yeah, this is probably not right. Yeah. I don't think I'm getting one of these, like, less than 1 minute. 40 seconds on the clock, okay. Minimum value. Let's just look at this one. It's like, why not? All these are pretty small. You have at most 100 of them that actually attain values. So if you assume that, and since they sort of balance out, okay, there's no way this is enough time. But okay, time's up. So I'm gonna have to check the answers now. Download the answers. Okay. So we got this right, we got that right. Oh shoot, we got this wrong. Dang. Oh no, got this right. Got this right. Got this right. 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 9 is A, oh shoot. Wait, series? No, 9 is B. Okay. You have like some typos. 10 is E. 11 is A. 12 is C. 13 is D. 14 is A. And then 15 is A. Okay. So 16 is a blank. And then like 17 is D. Okay, so I got all the questions I answered right. So then, and since I left the others blank, so that would be 16 times 6 plus 9 times 1.5, so that's 95. 96 plus 10.5. So that's 107.5. I mean, that's like really mid since I qualified for USIMO, but I haven't been doing math comps in a super long time. So yeah, I don't know. I mean, there's definitely a lot of space to improve. I guess for me though, like the biggest thing is to get the easy questions quickly, which is like harder when I'm trying to do this live. So, but I guess this is good for like the first time experience. Okay, let's look at 16. Split into 4 pairs, yeah, did see that. Let's see, choose. Okay, yeah, the analysis totally makes sense. That was similar to what I thought, but I just didn't expound on that idea. So these are like pairs. And since there's an order between them, once you choose the numbers, the pair is like fixed. okay, so the case is evens are in different pairs. And then there's only wiggle room for the odds. So yeah, so that is 4 fact. And then, okay, so if the evens are in pairs 1 or 3, so then they can either be in 1 or in 3. Or 1 and 3. So if they're in pair 1, then you have, again, that's some wiggle room. Okay, so if they're only in pair 1, then you have 2 of them. Or how about if they're both in, like, if they're in pairs 1 and 3? So then it's 4, choose 2. Or if they're in pair 1 or 3, and the order really doesn't matter. So if they're in pair 1, they can only be in pair 1, so then it's 2 evens split between 3 of them. And then after that, you are choosing 2 from 4 for the remaining pair, and then they just go in. Yep, okay, yeah, this is right. So this is 36, this is 6, this is 24. And the total number of ways to count this is 66. Oh, wait, no. I have to multiply this by 2 again. So, the solution to this with casework, so then this is evens in each. This is evens in 1 and 3. So this is evens in 1. So then A1, A2 must be 2 even numbers. And to choose them, you have 4 choose 2. And then you have 6 remaining even numbers that, or 2 remaining even numbers that can pick any one of the 5. Or it's 6 choose 2 minus 1. Wait, no. Okay, I'm just gonna 2 and 4 must be in pair 1, 6 and 8 must go into different pairs. Oh, why is that? Oh yeah, the evens must be increased. Okay, I see. So then A1, A2 has to be 2, 4. And then yeah, it's 3 choose 2 to see where 6 and 8 go into. And then since 2 and 4 are chosen, it's 1, 3, 5, 6, or 1, 3, 5, 7 that's remaining. So 4 ways to choose the one that goes with 6, and then 3 ways to choose the one that goes with 8. So 12, 3, so that's 36. And then likewise, if if pair 3 has 2 evens, then it has to be either 4-6 or 6-8. There's no way it's 2-4 because then you'll have to squeeze 6 and 8 into 8 cents. So if it's 4-6, then 2 has to be in one of these. So then 2 has 2 options. And then 2 has 4 options after that. And then 8 has 3 options. And then if it's 6-8, I think it's likewise. But then the order is determined, so 2 has to be in there and 4 has to be in there. But it's still 4 times 3, and the remaining 2 go in there. So this is 36 again, 36. So then that's 30, 36, 72, 102. Okay, so the answer is 102. So that gives D. '17 was a misread. Like, the misreads are super annoying. Okay, so for 18, okay. This is an interesting question. Okay, I get the idea, but I wouldn't have been able to come up with something like that while I was actually solving the problem. But basically, the idea is this. I think maybe you can like come up with like, or try to solve like an easier problem. Like if you look at like, instead of 1 to 10, you look at 1 to 3. And then you notice that maybe the total number of students is like, I don't know, 3 to the 2 to the 3rd. So that would be like 24. And then so if you notice these patterns, and then you can guess like 3072. And this is just a proof to that. So this would be like the engineer's induction. Which makes sense. Okay, how about 19? 19 is geo. I didn't even try 19. Like, honestly, I could probably give it a shot. ABC is isosceles, and then points are given. D. Circle passing through B, C, D, and 6. Okay, so it's just, I think I can do this with like
synthetic geo, or maybe like coordinate bashing. So ABC. Okay. Circle passing through BCD. Oh yeah. BC. So it's then this is the circumcircle. Intersects AC at through C perpendicular to AB at Q. So then like something like that. If PQ squared is equal to okay, yeah. This is just some bashing. I think like the fastest way is actually to bash. Since AB and AC is 4, but like A is like almost irrelevant. AB is 2√3. And then so like D is CD is 2, right? So you combine that with the fact that this is 60 degrees. 60, so this is 30 again. And then this is √3. It does not look like √3. No, wait, hold up. Oh, this is 60. Oh, this is equilateral. Then maybe there's like a synthetic solution that I'm not seeing. So the numbers are like really friendly, actually. Oh wait, no. This is 1, 0. Whoops. And then CD is 2. So no, so only this is only that's 60. But then BC is still 2. And D is on site AB. Since AB is 4. Okay, yeah, no, this isn't 60 either. Okay, yeah, so the solution says it's synthetic. I'm sure I can bash it though. So the idea is like find D and then plug it into the general circle equation to get like the equation for this circumcircle. And then you just combine the equation for the circle with the equation for AB and also or for CH really. She said at this point is H, and then for AC, and then just solve. So that would take like around 10 minutes of computation. Okay, looks like my stream is like almost dead. We're just gonna look through these questions. Okay, another geo. All these have synthetic solutions. This is a number theory, okay. This is an ellipse and geo. So iterative. Okay, well, that has been it for tonight. I'm actually gonna sleep soon. So yeah, thanks for watching. I didn't do that great, but we'll get better. Okay, I'll see you guys.